Hello, this is Dr. Mears. Today we are going to be going over our do, check, and corrects for our unit on logic, actually our chapter on logic. So for section 9.8, these were your do, check, and corrects. It was a pretty large section. I'm not going to be able to do all of these, so what I did is I looked through the book and I tried to align it to what you're going to be having on your formative assessment. And so these are the ones I'm going to try to do as quickly as possible. I do not want to take a lot of time, so let's go. Okay, so on page 403, which is the first ones that you're supposed to do, you had to do number 2, 4, 5, 7, and 8. I'm going to be doing 2, 5, and 8. Number 2, it asked you to analyze the arguments. It actually gave you these two, and it had the word and separating them. What you're supposed to do is really just split it up to 2 and then test it. So let's do A first. We have P and if P and Q, then P. So we have to set up true, true, false, false, and Q, true, false, true, false. Now we need to do P and Q, as there are no negations here or parentheses. So remember, and is both true at the same time. So I need TT to be a true. So here we go, true, true, this is false, and this is false. So this is the only true for and. Now we need if P and Q, then P. So what we're going to look at here is this first column. So this is the first column that you have to look at, and we are going to go to P, so P is the second. So I don't need this anymore, that's out. So this is out, and so what I'm going to be doing is I'm going to be looking from here over here. So I have to look that way. And remember, it's when the first one is true, so this one is true, and the second one is false, this one is false. So if it goes TF, that's the only way that I'm going to get a false. Are you ready? That's the only way I get a false, if it's T and F. So let's do it. TT, that's fine. FT, that's fine. FF, that's fine. And FF, that is fine. So this is actually very valid, and it's actually a tautology. So this situation where I had the T and then the F did not happen, so I did not get any falses. Now let's look at if P or Q, then P. So again, set up true, true, false, false, true, false, true, false. Remember, or could be one or the other or both, so I need at least one T to get a T, so that's fine, and this is where it's going to be false. So there's no true here, so that's why it came out to be false. Now, if P or Q, so this is the first one we're going to look at. Then we're going to go to P, so this is the second one we're going to look at. We have an if-then connector, so this has to be true, this has to be false for us to come out with an overall false argument. Remember, that's the only way is when the number 1 is true, and then the number 2 is false. So let's see if that event happens. True, true is fine, true, true is fine, true, false. Here it is. So we're not looking at that. Q is out, remember. We're looking at true, false. That's the way it comes out to be false. So that's false, 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 and that is absolutely fine. So this argument is actually invalid because our last column here has a false. Okay, number 5. Now I wrote these out because on your formatives, we're going to write them out. On paper 1 and paper 2, they write them out for you as well. So this is nice because you don't have to think about doing them out. You just have to make sure that you understand the connectors. So let's go true, true, false, false, true, false, true, false. What we have to do is we have actual 2 statements joined by this or inclusive. So the first one we're going to have to do is P and Q, which is this one. The and, remember, both have to be true. So true, true. And everything else is false because it has to both be true. Now we're going if P and Q, then P. So we're going from here, number 1, to here, number 2. So the only way that this can be false with this connector is if this one's true and that one's false. So that's fine, that's fine, that's fine, and that's fine. Now we're going to go the other way. We're going to go if P, then P and Q. So we're no longer going this way. We have to flip it. So what we're going to be doing here is we're going from number 1 now. So this is now number 1 to number 2, to number 2. So we're going the other way. The connector is the if-then, so that means this is true, this is false to come out with an overall false. So let's look to see what we have. So again, that's out, and we're going from here to here now. So we have true, true, true. True, false, here is that situation where it's going to come out to be false. False, false, that's fine, and false, false, that's fine as well. Okay, now we need to go from, and I'm going to label this number 3 to number 4. So let's locate these. Number 3 is if P and Q, then P, so this is number 3. Number 4, so that's out. This is number 4, so we're going from 3 to 4, so we're looking at these two columns. The connector is our or inclusive, so it means one or the other or both as long as I have a truth there. So let's look to see. True, true, it's fine. True, false, I got a true. True, and true. So this is valid. It's actually a tautology because the last column is all true. I'm not writing that out every time for you right now. I just want to do the truth tables and show you what happens. I don't want to not waste time, but I don't want to take up time writing it out. You know that you need to write out that the last column, it's all trues here. Okay, and the last one, this is number 8. Here we go. We have not P or inclusive, not Q. So if not P or not Q, then not P and Q. So these are different. Let's see what happens. We start off the same way. True, true, false, false. True, false, true, false. Not P. So what we have to do is we have to look at the P column and negate it, meaning our trues turn to falses and our false turns to trues. We have not Q, so we look at the Q column. Again, we're going to be taking the flip of these, so false, true, false, true. Now we have to do not P or inclusive, not Q first, so I'm looking for at least one true. So we're going from not P to not Q, so from this column to this column. False, false, no, we need a true. False, true is fine, true, false is fine, and true, true is absolutely fine. Now we have to do what I did is the what's in the parentheses, P and Q. So we're going to go back to the original P and Q. And remember, they both have to be true to get a T. Regardless, everything else will be false. So true, true is a true. True, false. These are all falses because there's a false there. So the only way was that one. Now we have to negate what we just did, P and Q. So negation, I'm just going to look at this column. I'm just going to flip everything. And the last one, I'm going to go from not P or not Q to number 2, not P and Q. So what we're going to be doing, I'm just going to erase these. We're going to be looking at not P or not Q, and we're going all the way over here to not P and Q. So this column is out, and I'm actually going from here to here, from here to here. So the order that they give you here is how we read it here. So let's look at our connector. We're doing an if-then connector. So the only way we can have a false is if the first one's true and the second one is false. So if this first one's true and the second one is false, we're going to come out with an overall F. That's the only way. So let's look. False, false is fine. True, true is fine. True, true is fine. And true, true. Wow, we got all these tautologies. I did not do that on purpose. Last column is valid. It's a tautology. And that is number 8. If you need to pause and go back because I'm going so fast, please do that. If not, hang on because we're going to page 406. So page 406, and I'm doing number 3. I wrote it out. It says Isaacs will pass the math test or drop out of the IB diploma. I did not write this one. It's from the book. He does not drop out of the IB diploma, therefore he passes the math test. So I know you have this or here because this is going to be This is going to be P, pass the math test, and drop out of the IB diploma program. This is going to be Q. However, you have to be careful because this is an if-then. So if P, then Q. I know it has an or, and that is really confusing, but we do start with a if-then statement. So if P, then Q. Okay, he does not drop out. So they're telling you he does not drop out. So since that is the only option, it's going to be and not drop out, so and not Q. We're starting a new sentence. Remember, starting a new sentence, you have to put in your grouping symbols. So this was the first sentence. That was the second sentence. Now we're on the third sentence. Therefore, your therefore is an implication. So we're going to do that double arrow. Therefore, he passed. He passing is P, and so those are the symbols. This does take time writing in symbols. This complex statement does take time writing in symbols. Again, this or may have thrown you off. It is an if-then statement. I'm sorry if it threw you off. Okay, here we have our truth table. I set it up for you, so we have to prove this is the statement that we did here. We have to prove if it's going to be valid or invalid. So let's see what happens. We have if P then Q, so we're going from P to Q. So the only way that this could be false is if P is true and Q is false. Remember with this implication here. So true, true is fine. True, false is not. That's where we can't have. False, true is fine, and false, false is also fine. Okay, now we're going to be going. Oh, I forgot one, didn't I? I forgot not Q. So you know what we're going to do? We're actually going to add a little column in here because it's not too late to add a little column. And I usually add not Q. And not Q gives you a false, true, false, true. So now we're going to go from if P then Q and not Q. So we're going to be looking at if P then Q over here to our not Q, our little column I just added in. So remember the and, they both have to be true to get a true. This is and, so both true. False, true, nope. True, false, nope. False, true, nope. True, true, absolutely fine, that's a true. And now we're going to be going from this long statement that we just did here, so that's number 1 right here, and we're going to be going to number 2. So we're going to be going all the way back to P, which is number 2. So these are out. We are just looking from this one, false, 2, jumping over this one, true. And that's the order. It's an implication. So when number 1 is true, T, and number 2 is false, F, that's the only false we're going to get. That's it. So let's look. False, true, that's fine. False, true, that's fine. False, false, that's fine. Ooh, here it is. True, false, that's not fine. That's false. And this is going to be invalid. I feel like it shouldn't be, but we'll see. False, true, true, false. Yeah, okay. There we go. That's where we got it right here. Okay, so that is invalid. Let's go to the next one. Page 408, number 2, it says tautology. We have not P or Q, if not P, if and only if not P or Q, then not P and not Q. So here we go. I'm making sure my nots are in here so I don't have to add in another column, and I believe I have everything. So this is going to be true, true, false, false, true, false, true, false. Not P, so we look at this first one and flip everything. Not Q, we look at the second column and flip everything. P or Q, or remember one or the other or both. So this one to this one, I just need a T and it's going to turn true. So these are all true. And the last one is the one that's false. Not P or Q. So what I want to do is, because this is in the parentheses, I'm just going to take this column and flip it. So that's what that negation means. Now I have to go to not P and not Q. So here's where it has to be true and true to be true. So we're going to go from not P, this column, to this column. False, false, nope. False, true, nope. True, false, nope. True, true, yep. There you go. And lastly, we have if and only if. Remember, if and only if, the trues that we're going to get is when it's the same. So we're looking for the same to get a true. That's what we're looking for right here. We're going to go from number 1 to number 2. From number 1 to number 2 right here. From here to here. We're looking for the same. Same, yes, true. Same, yes, true. Same, yes, true. And same, yes, true. So this is valid. It's actually a tautology because the last column is always true. There we go. Okay, and this is page 411, 1 through 3. I'm actually doing part H. I already wrote most of it out so that I wouldn't have to spend time writing it out. The original is, if the sum of two integers is even, then the two integers are both even. They asked you if it was valid or invalid. If invalid, give a counter example. So this is what they want you to do. They want you to try to think of a number where the sum is even. That's the first thing. The sum is even because that's P and that's Q. Then the two integers are both even. So we have to think, can I find a number whose sum is even, but the integers are not? And I did. So this is invalid because I can give the example 3 and 7 are both odd, but their sum is even. This one is saying that both sides are going to be even. So this is a counterexample, which makes the entire statement invalid. Then they wanted you to write the converse. The converse, if two integers are both even, then the sum of the two integers is even. I flipped Q and P so that this is if Q, then P. This is valid. The inverse is if the sum of two integers is not even, then the two integers are not both even. So this is not, if not P, then not Q. Oops, my bad. If not P, then not Q. There we go. So you had to negate both of them. And then the contrapositive is if the two integers are not both even, then the sum of the two integers is not even. So this is actually negating and flipping, not Q, then not P. And this is where your counterexample comes in. If the two integers are not both even, 3 and 7, then the sum is not even. That's 10. So this counterexample can actually be used to say that this statement is invalid. So we got two valid statements for the converse and an invalid statement for the contrapositive. And that has been page 411. And on to our last one. We're looking good at 16 minutes and 21 seconds. Here we go. We have if P and Q or, sorry, not if. I was so used to doing those ifs. P and Q or P and not R. So now we're introducing that third letter. So we're going to have more choices. So the trues, we get 4 trues followed by 4 falses for P. We get 2 trues followed by 2 falses for Q. And for R, that's who gets true, false, true, false, true, false, and true, false. So we have 8 now. We have 8 different ones now. Not R, we just take the R column and we flip it. So false, true, false, true, false, true, false, true. P and Q, so this is the same thing. We're looking for true, true to come out true. So we're looking for a TT here. And we're going to go from P to Q here. So we're just looking for where they're both true. So that's true, false, false. And I believe everything else down the line is false here. 1, 2, 3, 4, 5, 6, 7. I always make sure that I have 8 because I go so fast. Sometimes I lose one. So I'm checking my work. Now it's P and not R. So again, we're looking for 2 trues to be a true. We're going from P to not R. So we're jumping over Q and R here. So we don't need these. We're going from P to R. So 2 trues, true, true. Oops, sorry. We're going from, you know what? I'm going to do this. I usually put a number 1 to number 2. That really helps my eyes. I put an arrow in because that's what we're doing from number 1 and number 2. So let's do that. Now it makes it better. We're looking for 2 trues again. True, false, no. True, true, yes. True, false, no. True, true, yes. False, false, no. No, no, and no. Okay. And the last one, we're going from number 3, which is P and Q. That's number 3. Or inclusive, so 1 or more T's, P and not R, which is number 4. We're going this way. Oh, I love when they line up and we read it from left to right. So we're looking for at least 1 T. So let's do this. True, true, nope. True, nope, 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 nope. So this is definitely invalid. I-N-V-A-L-I-D. Invalid because, as you can see, definitely the last column we have some. So this has been the review. I actually would like to go back and check, and I'm going to do that. I feel like something happened here with page 406, number 3. I'm not sure if I missed something here. I feel that this should be true. 1 true, 2nd false. But the answer key says valid, and I'm getting invalid. So I'm going to have to go back and check on that. If it's wrong, then I will definitely make a note. But right now, it seems to be coming out invalid. So this has been Dr. Mears on Logic Truth Table Review for the Do, Check, and Correct. Hope it helps.